Hello and welcome to Oracle Cloud Infrastructure 2024 Architect Professional Learning Path. This learning path will help you prepare for the certification exam, which is a hands-on performance-based exam, and also help you plan, design, and implement solutions on Oracle Cloud Infrastructure. My name is Samvit Mishra, and I'm a Senior Principal OCI Instructor at Oracle University. And we have got an incredible team that has collaborated to bring you this course. Along with me, you will hear from my colleagues Orlando Gentle, Saurav Patil, Mahendra Mehra, Rashmi Panda, Susan Jang, Tijo Thomas, and Sergio Castro. This course is designed to help you prepare for the Oracle Cloud Infrastructure 2024 Architect Professional Certification that serves as the next level of credential for those who have already earned an OCI Architect Associate title. Hence, this course is intended for solution architects and cloud architects who design, optimize, and manage cloud solutions to meet business requirements and technical constraints. As a professional level solution architect, you are expected to fully understand cloud architecture principles that includes expertise on high availability, disaster recovery, multi-cloud, and hybrid environments. You should ideally hold the OCI Architect Associate certification before attempting the professional level. The associate level provides essential knowledge of OCI services and basic architectural principles that are critical for the professional exam. A minimum of 1 to 2 years of hands-on experience with OCI services is recommended. Now let's look at the course outline. We have 8 modules in this course. The first module focuses on high availability and disaster recovery. In disaster recovery, our primary focus will be on the full stack disaster recovery service. The second module is on cloud native technologies. We will learn containerization, Oracle Cloud Infrastructure Registry, container instances, Oracle Cloud Infrastructure Container Engine for Kubernetes or OKE, functions, and API gateway. Next, we will focus on infrastructure as code. We will have a look at Terraform commands and also master Resource Manager service. The next module is on databases. Basically, how do you implement and operate databases in OCI? So discussion on base database service and autonomous databases. Security is job 0. And as a cloud architect, it is your responsibility to have an overall understanding of OCI security service offerings. In this module, we will discuss OCI Bastion service, network firewall, certificates, web application firewall, and KMS, to name a few. In the next module, we will discuss our multi-cloud and hybrid offerings. We will talk about OCI Azure Interconnect, Oracle Database at Azure, and Oracle Cloud VMware solution. Migration is a key area for cloud architects, and hence we will also discuss Oracle Cloud migrations as well as how to migrate data and databases to OCI. The final module is on observability, where our focus will be on monitoring and logging. Before you move on to the next modules, make sure that you take the skill checks that we have provided to test your knowledge and solidify your understanding of the topics covered. At any point of time, if you have specific question about the course material or need extra help, fill out our Ask Your Instructor form. Our expert instructors will get back to you as soon as possible with personalized support. We also want you to get the most out of your learning experience, which is why we have created this community space where you can connect with other learners and subject matter experts. If you have any questions or want to start a discussion on a particular topic, this is the place to do it. So don't be shy. Join the OU community today and start collaborating with your fellow learners. We can't wait to see what you bring to the table. I would also like to offer some tips for increasing retention and giving you the best chance to pass the exam. We suggest that you take notes for anything pertinent, but also remember that transcripts are available for every video. Schedule breaks each hour and move around. Don't stay stationary in front of the computer for too long. The course also features a lot of hands-on demonstrations. We recommend you go through them. As I previously mentioned, complete all the skill check sections of this course. That will help you in reinforcing the concepts learned. You should also review the exam preparation course and take the practice exam before taking the actual certification exam. I hope you are excited to start the course. On passing the certification exam, you will earn an OCI Architect Professional Certified badge. So once again, thanks for enrolling. Let's begin. Hello and welcome. In this lesson, we will talk about our architect certifications and courses as well as prerequisites for this course. So let's begin. As shown in this slide, our architect certifications and courses are categorized into two broad segments, generalists and specialists. OCI Generalist Cloud Architects boast comprehensive knowledge across core OCI services. So that includes compute, storage, networking, database, security, cloud native, and automation technologies. Specialist cloud architects are distinguished by their proficiency in designing hybrid and multi-cloud architectures and in migrating workloads, data, and databases to Oracle Cloud Infrastructure. We suggest beginning your journey with the OCI Architect Associate certification to acquire essential knowledge and skills pertaining to core OCI primitives. Subsequently, you may opt to advance your expertise by pursuing the Architect Professional certification, thereby deepening your understanding of OCI services. Alternatively, if you seek proficiency in multi-cloud environments, the Multi-Cloud Architect certification offers a tailored pathway to hone your skills in this domain. For those who are keen to acquire practical insights into OCI migration solutions, the Migration Architect certification provides invaluable hands-on experience and expertise in designing and implementing migration solutions in Oracle Cloud Infrastructure. This slide showcases 4 distinctive certification badges for various Oracle Cloud Infrastructure certifications. Each badge represents a different level of expertise and specialization in OCI, highlighting the skills and knowledge required for cloud architecture and migration. The first one is OCI Architect Associate. Then we have OCI Architect Professional. This advanced certification builds on the Architect Associate certification, and it requires a deeper understanding of OCI services and the ability to design complex and scalable solutions. The third one on the list is OCI Migration Architect Professional. This certification focuses on the skills needed to migrate workloads to Oracle Cloud Infrastructure. And the final one is OCI Multi-Cloud Architect Associate. This certification emphasizes the ability to design and manage solutions that span multiple cloud platforms. This slide provides a clear breakdown of the specific topics covered under the OCI Architect Associate and the OCI Architect Professional certifications, highlighting the progression from foundational to advanced skills in Oracle Cloud Infrastructure. So as you can see here, when it comes to OCI Architect Associate, there is coverage for the core constructs, compute, storage, networking, and identity and access management. When it comes to OCI Architect Professional, you should have deep knowledge of cloud-native solutions, high availability and disaster recovery, security, databases, infrastructure as code, designing and integrating multi-cloud and hybrid solutions, migration strategies, as well as observability, which includes discussion on monitoring and logging. All right, this marks the end of this lesson. Let's begin the course. Welcome to this lesson on refresher of identity and access management. So let me open up a whiteboard and I will write IAM in the center. So primarily this identity and access management service refers to how we manage users and their access to resources within Oracle Cloud infrastructure. So think of authentication, think of authorization, and we also talk about policies in this identity and access management service. So what are the things that we have already discussed in OCI Architect Associate course? So the first topic is identity domains. So you should have a good understanding on how to create an identity domain, how to manage an identity domain. And this identity domain is nothing but, think of it like an isolated partitions within OCI. And why do we do that? We do that to ensure that we are able to organize identities and we can enforce password and security policies for those identities. So that is the first topic, identity domains. You should have a good understanding of this topic. The next topic that you should be thorough with is how do we manage users and groups? So how do we add user? How do we modify? How do we organize users? And same is the case with groups. And why we typically require this knowledge? To simplify and streamline access control. Then there is another discussion around administrator roles. So you should be very familiar with the guidelines for designating administrative roles so that you are able to manage the capabilities within the domains and in turn ensure effective administration. The next topic that we have covered is related to IAM policies. You should be very thorough with the syntax. You should basically understand the syntax that is used in IAM policies. And you should also understand the policy actions as well as the placement. So in a way, you should understand how to define specific actions that policies allow and how to determine the appropriate placement of these policies. You should also have a very good understanding of compartments, how to structure resources into compartments to enhance organization and access controls. You should also understand quotas and budgets, how to set limits and budgets for resource usage within individual compartments so that you can manage the costs and resources efficiently. The next topic deals with granular access control. And this is where you should have a very good understanding of policy inheritance, conditional policies, tag-based access control. So what is policy inheritance? You should understand how policies can inherit permissions from parent compartments. And using conditional policies, you can implement policies based on conditions such as request or target attributes. And you can also use tags to manage access permissions based on resource metadata. Then you should also understand what is a network source, how you can restrict access to resources based on specific IP addresses
and virtual cloud networks to enhance security. And lastly, we also talk about dynamic groups. So how to create a dynamic group, what functionality this dynamic group provides. So you should understand how to create a dynamic group that allow resource-based identities using attributes like compartment OSID, instance OSID, and it basically provides more dynamic access control. So these are the topics that you should understand when it comes to identity and access management service. So the intention of creating this lesson is to talk about the services that you need to know before you proceed with the Architect Professional course. This marks the end of this lesson. Thanks for your time. Welcome to this lesson on refresher of the networking concepts. Let's get started. So let me start with whiteboarding. And in this lesson, we will talk about what are the concepts that you should be aware of when it comes to networking. And we have discussed all these concepts in our Architect Associate course. So primarily, if I talk about networking, the very first thing that you should know is the basics of virtual cloud network. And when I say basics, I mean the likes of route tables, gateways, VCN security. So primarily a knowledge of all the VCN components. You should also be aware of the IP management concepts. By IP management, I mean what is a reserved IP address, reserved public IP. How do we bring the IP addresses that you own to OCI? That is what is your bring your own IP address. And you should also be aware about the concept of public IP pools. The next topic that you should be aware of is connectivity. We can divide this connectivity into multiple branches. The first is peering. You should have a good understanding of both local and remote peering. Another component that is very critical when it comes to connectivity is dynamic routing gateway. So you should also have a good knowledge of dynamic routing gateway. Then the two mechanisms by which you connect your on-premises environment to OCI, site-to-site VPN connection, and fast connect. Along with these topics, you should also have a very good understanding of transit routing. That is also critical. Now, after connectivity, the next topic is load balancers. You should have a good understanding of the two types of load balancer. Load balancer and network load balancer. Along with that, you should also know what is a web application acceleration and how does it utilize compression and caching. The next area is DNS management, where you should have a good understanding of the difference between public DNS and private DNS. What is a private view? And traffic management steering policies. That is also critical. The last topic that you should be aware of is network Command Center. We call it Network Command Center Services, and there are several services that are part of this offering. For example, Inter-Region Latency, Network Path Analyzer, Network Visualizer, Capture Filters, Virtual Test Access Points. So these are some of the topics that you should be very thorough with before you consume Architect Professional course. And just to give you a sense of what we covered, if I take you to the OCI console, click on the hamburger menu, click on networking. So you can see virtual cloud networks, web application acceleration, load balancers, DNS management, customer connectivity, IP management, and network command center services. So these are the services that we cover in OCI Architect Associate, and we really go deep dive when we cover these services. So the intention of showing you this is to ensure that you have consumed the Architect Associate course before you consume the Architect Professional course. This marks the end of this lesson, a quick refresher on networking. Thanks for your time. Hello and welcome to this lesson on the refresher for compute services. So let's get started. So let's discuss what we have already studied in the Architect Associate course. So primarily in the compute service offering, you work with images and shapes. When I say image, there are different types of images. For example, platform images, custom images. There's also a concept of bring your own image. There are different types of shapes, a special mention to GPU shapes. Then you also need to understand the difference between bare metal versus virtual machines versus dedicated VM hosts. We also looked at how you can generate an SSH key pair, then how you can launch a compute instance, and once you have the instance, how do you connect to it? Then there was a discussion around the different capacity types. For example, preemptible instance, capacity reservation, how it works, dedicated virtual machine host. We also looked at the different scaling mechanisms, both vertical scaling as well as horizontal scaling. And when we talk about horizontal scaling, we talk about auto scaling. So what are the components when it comes to compute auto scaling? You should also understand how the operating system management service works and what do you mean by instance, console, connection, and what are its use cases. We also discussed what is a burstable instance, what is a shielded instance, and what do you mean by confidential computing. Lastly, you should also have a good understanding of the infrastructure maintenance concepts. So these are the topics that we have already covered in Architect Associate course. Ensure that you go through them before you proceed with the Architect Professional course. This marks the end of this lesson. Thanks for your time. Welcome to this lesson on refresher of the storage services. So let me open up a whiteboard and let's talk about what we have discussed in Architect Associate course with respect to storage. So basically there are three types of storage offerings: object storage, block storage, and file storage. And we will look at each one of these one by one. So first, let's look at object storage. So in object storage discussion, we have seen what is object storage and how do you create a bucket. So once you create a bucket, you upload data inside the bucket. So we call this data as object. So creation of a bucket, uploading data, managing objects, managing buckets, all this we have seen. Then how to configure multi-part uploads. You should also know how you can upload objects using multi-part upload functionality. Then the three types of object storage tiers, along with discussion of the concept of auto tiering and how it is different from object lifecycle management. So this is also something that you need to have a good understanding of. Then other features like object storage replication, object copy, and versioning. How to enable versioning. You should also have a good understanding of how to configure retention rules and what are the two types of retention rules: time-bound and indefinite. Finally, how to configure the security of object storage. So under this, you will have things like pre-authenticated request, how to use customer managed keys, and logging. So these are the topics that you need to have a good understanding when it comes to object storage. Now let's look at block storage. So you should understand what is a block volume, what are the different volume attachment types, basically iSCSI and para-virtualized, what is the difference between them. Then you should also have a good understanding of the volume access types, whether it's read-only or read-write. We have also seen how we can configure multiple instance volume attachments. Along with block volume, you also need to understand what is a boot volume. Then with respect to block volume, you need to understand the various performance levels of the block volume and the concept of dynamic performance scaling. So this is also something that you should know. Now let's say you have a block volume. How to perform the resize of that block volume? How to resize a volume? And let's say you have a block volume. How do you take the backup of this block volume? How do you clone this block volume? And what is the difference between backing up and performing a clone? And let's say you would like to replicate a block volume from one region to another region, or maybe to another availability domain within the same region. So we have also seen in our Architect Associate course how we can configure cross-region and cross-region and cross-availability domain replication. We have also seen what is a volume group and how we can configure a volume group. Lastly, we also touch upon the security aspects of block volume. So with that, we'll now move on to the file storage. And let's quickly look at what are the topics that we have learned in Architect Associate course. So first is file system concepts. Then how to create a file system and mount a file system. We also looked at how you can configure NFS export options and file system paths. So you have a file system, how you can configure the snapshot of the file system, how you can clone the file system, and how do you set up in-transit encryption. Lastly, we also looked at how to understand file system usage and metering. So these are the three types of storage offerings: object storage, block storage, and file storage. And we have covered each of these services very thoroughly in our Architect Associate course. So this marks the end of this quick refresher. Thanks for your time. Hello and welcome to this lesson on reference architecture for security services. Let's get started. So as you can see here, this is a reference architecture where we are leveraging multiple security services. For example, you see that this is your web application firewall. This is network firewall. This is certificates. This is the key management service, Bastion service, vulnerability scanning, security zone, and identity and access management service. So these are the security services that we are leveraging in this reference architecture. Now in this reference architecture, I am going to discuss 5 major aspects. The first aspect is how do we manage multiple accounts and access to resources? So the answer to this aspect is by using identity and access management service. So in identity and access management service, we create and manage users, groups, policies for access control. The second aspect is how do we deal with misconfiguration and how do we work with private endpoints? The solution for misconfiguration is OCI security zones. In OCI security zones, we can enforce security policies that can help us prevent misconfiguration. And what is the solution for private endpoint access? That is your OCI Bastion service. Using OCI Bastion service, you can configure secure access to private resources. You can also configure time-limited access and activity logging.
So that was the second aspect. The third aspect deals with encrypting data in transit. So for that, we have OCI certificates service. And using OCI certificate service, we can encrypt communication. So this basically provides automated certificate management. Now, the fourth aspect is protecting encryption keys and secrets. The solution for this is OCI Key Management Service. So OCI Key Management Service provides secure key management, HSM protection, and regular key rotation. The fifth aspect is regarding how to protect web application from malicious traffic and common exploits or attacks. The solution that we have is leveraging web application firewall and network firewall. So what do we typically do here? We define web application firewall policies. We filter or block malicious traffic. It also provides continuous threat updates and IP or protocol-based security rules. So these were the 5 aspects that I quickly wanted to discuss in this reference architecture. This marks the end of this lesson. Thanks for your time. Hello and welcome to this lesson on OCI multi-cloud reference architecture. Let's get started. Here we are considering a service which is Oracle Database at Azure. Oracle Database at Azure is the Oracle Database service running on Oracle Cloud Infrastructure, co-located in Microsoft Azure data centers. So on the left side, you can see Azure, and on the right side, you can see OCI. This service, Oracle Database at Azure, is deployable across multiple Azure availability zones and regions to ensure business continuity and cloud resilience. In this reference architecture, we'll talk about some best practices for a cross-availability zone Oracle Data Guard solution. You can see that in this architecture, there is a containerized application in Azure Kubernetes Service. The container images are stored in the Azure Container Registry. So users are going to access the application externally through a public load balancer that you can see here in this architecture. The primary database is deployed on Exadata VM cluster in Azure Availability Zone 1. The application VNet connects to the database VNet via VNet peering, and the applications in Azure Kubernetes Service access the database in the client subnet through the delegated subnet. The secondary database is deployed in a separate availability zone in the region. In our case, it is Availability Zone 2. Oracle Data Guard or Active Data Guard can be used to replicate the data from the primary database to the secondary database. And in case of cross-availability zone database replication, we recommend Active Data Guard. On the right, on the OCI side, you can see that there is OCI Object Storage and OCI Vault. The database keys are stored in OCI Vault, and the automated backups are stored in OCI Object Storage. So with respect to this architecture, there are some architectural best practices principles. For example, database backups and restore operations are achieved using OCI Object Storage, and that is the built-in Oracle Database automatic backup mechanism. So we are leveraging that. The application tier in the architecture is spanning 2 availability zones. In this architecture, we are leveraging multiple Azure availability zones to ensure the business continuity and cloud resilience. This marks the end of this lesson. Thanks for your time. Hello and welcome to Disaster Recovery Reference Architecture. Let's get started. This architecture shows a multi-region disaster recovery implementation using OCI Full Stack Disaster Recovery Service. As you can see here, there are two regions, OCI Region 1 and OCI Region 2. There is also a VCN in each region, and the VCNs are paired using Dynamic Routing Gateway. And you can see that there are two dynamic routing gateways, each attached to the respective VCN. Full Stack Disaster Recovery provides comprehensive disaster recovery capabilities for all layers of an application stack that includes infrastructure, middleware, database, and application. Here you can also see that we have two DR protection groups, primary DR protection group and standby DR protection group. So what is this DR protection group? So DR protection group organizes the components of a full stack application so that you can recover all the components together to restore the full stack application. You can also see that there's a DR plan, which is nothing but an automated DR workflow. Think of it like a runbook, and it can perform disaster recovery for all resources in the primary DR protection group. There are two types of DR plans, switchover and failover. You also see that inside a DR protection group, we have WebLogic or SOA, and there's also a database. Oracle WebLogic Server for OCI enables you to quickly create your Java Enterprise Edition application environment on OCI that includes an Oracle WebLogic Server domain. So you can basically configure and provision your domains along with any supporting cloud resources. It can be your instances, it can be networks, it can be load balancers. And similarly, SOA Suite on Marketplace, it provides a PaaS solution for running applications in the cloud. You also see database in the architecture. That's also part of DR protection group. So it can be Oracle-based database service, or it can be Exadata database service. It can also be Oracle Autonomous Database Serverless. Now, what you also see in the architecture is that this is making use of DataGuard. So Oracle DataGuard provides comprehensive set of services that provides one or more standby databases to enable production Oracle databases to remain available without interruption. So Oracle DataGuard is going to maintain standby databases as copies, and if the production database becomes unavailable because of any planned or unplanned outage, then the Oracle DataGuard can switch any standby database to the production role, and which means that you are basically minimizing the downtime that is associated with the outage. So in this architecture, we looked at the components of full stack disaster recovery service and how you can implement multi-region disaster recovery solution using OCI full stack disaster recovery service. This marks the end of this lesson. In one of the upcoming modules, we are going to have a deep dive discussion of full stack disaster recovery service. So thanks for your time. Hello and welcome to this lesson on reference architecture for high availability. Let's get started. Multi-tier architectures are common in traditional on-premise enterprise applications. Therefore, let's use an example 3-tier enterprise application to show you how you can use OCI high availability capabilities. The architecture that you see here shows an example enterprise application in a single region high availability configuration. Please note that a region is composed of one or more availability domains. In OCI, it is either 1 or 3. Now in this architecture, you see 2, but remember this is just for representation. Technically, it's either 1 or 3. Now each availability domain contains 3 fault domains. Here you see that inside an availability domain, I have represented just 2 fault domains. That is again just a representation. Technically, each availability domain will have 3 fault domains. So I just wanted to call that out to avoid any sort of confusion. Oracle Cloud Infrastructure provides the building blocks
that let you enable high availability for your infrastructure. The example enterprise application uses services within the OCI concepts of regions, availability domains, and fault domains. The use of multiple availability domains and multiple fault domains within each of those availability domains increases redundancy and eliminates single point of failure. As we already know, availability domains are isolated from each other, they are fault tolerant, and they are very unlikely to fail simultaneously. And at the same time, because availability domains do not share infrastructure like power, cooling, or the internal availability domain network, if there is a failure at one availability domain within a region, it is unlikely to impact the availability of others within the same region. In this architecture, we see that there is a VCN that is spanning multiple availability domains, and then there are 3 regional subnets, 1 public and 2 private. Load balancer is deployed in the public subnet, and web app tier backends and the database is deployed in the private subnet. You can also see that the backend sets can span multiple availability domains and hence provide high availability for your architecture. When you add an autonomous data guard standby database, the system creates a standby database that continuously gets updated with the changes from the primary database. You can use autonomous data guard with a standby in the current region, which is a local standby, or with a standby in a different region, that is a cross-region standby. Very quickly wanted to show you this 3-tier enterprise application and how it leverages OCI's high availability capabilities. In one of the upcoming lessons, we are going to have a detailed discussion of high availability. This marks the end of this lesson. Thanks for your time.
Hello and welcome. In this lesson, we will talk about high availability on Oracle Cloud Infrastructure. What is high availability? High availability is a characteristic of a system that aims to provide higher operational performance and uptime. To achieve that, redundant hardware and software are used to architect the system to remain available despite failures. By removing single points of failure, backup components will take place of failed components, that is the failover operation. A smooth transition from the failed component to the backup component determines the level of high availability of a system. On OCI regions, availability domains represent fault-tolerant structures that are isolated from each other and do not share any physical infrastructure. When multiple availability domains are present in a region, they are interconnected using low-latency connections, allowing replicated systems within the same region. Each availability domain contains 3 fault domains. A fault domain is a grouping of hardware and infrastructure within an availability domain. Fault domains provide anti-affinity. They let you distribute your instances so the instances are not on the same physical hardware within a single availability domain. A hardware failure or compute hardware maintenance event that affects one fault domain does not affect instances in other fault domains. One of the key principles of designing high availability solutions is to avoid a single point of failure. We recommend designing your architecture to deploy instances that perform the same tasks in different fault domains for one availability domain region, and if possible, in different availability domains for multiple availability domain regions. This design removes a single point of failure by introducing redundancy. Let's look how several components can help your system be highly available. Subnets act as a unit of configuration within the VCN. Subnets exist either in a single availability domain or across an entire region, regional subnets. Regional subnets facilitates the communication as they can cover multiple availability domains and is recommended over AD-specific subnets. The load balancing service improves resource utilization, facilitates scaling, and helps ensure high availability. It supports routing incoming requests to various backend sets based on the virtual host name, path route rules, or a combination of both. The backend set can span through multiple availability domains. Both private and public load balancers are redundant. Virtual IPs are assigned as secondary IPs on compute instances. This secondary IP can be reassigned to another instance for failover. Compute instances architecture can take advantage of multiple availability domains or fault domains when allowing your system to be redundant. When you set up a secondary instance that works if the primary instance fails, that is called standby. Standby mode is typically used for applications that need to maintain their states. When all the instances are actively participating in performing the same tasks, this is called active-active mode. When one of the components fails, the related tasks are simply distributed to another component. Active mode is typically used for stateless applications or applications that track their states in a broker or database. Sometimes failures happen because the instance's resources are exhausted. With autoscaling, you can create an instance pool, a group of instances, actively monitor and automatically react to that and scale the number of instances within the pool according to their load, either CPU or memory. Autoscaling is fully integrated with the load balance service that can distribute the request among the pool members. Object storage was designed to be highly durable within regions. Multiple copies of the data are stored across several servers in the availability domains. Data integrity is actively monitored using checksums. Corrupt data is auto-detected and auto-healed from redundant copies. Any loss of data redundancy is actively managed by recreating a copy of the data. All this happens automatically and no intervention is required. Block volumes are available within availability domains, and their underneath structure is highly available with multiple copies on different storage servers. If you need to copy data to a different availability domain, you can use the block volume backup feature that is created as a regional resource and restore it to the block volume on a different availability domain. File storage systems provide durable, scalable, enterprise-grade network file system that's ideal for enterprise applications that need shared files and are similar to a network-attached storage. Redundant connectivity is an important part of a highly available system. When using IPsec VPN, the Dynamic Routing Gateway offers multiple VPN endpoints so that each IPsec VPN connection can consist of redundant IPsec tunnels that use static routes to route traffic. To ensure high availability, you must set up VPN connections within your internal network to use either path when needed. When using Fast Connect, you can either connect directly to OCI routers in provided point of presence, called POPs, or use one of Oracle's many partners to connect from POPs around the world to their OCI networking resources. Oracle provides features that allow you to build fault-tolerant connections, including multiple POPs per region and multiple Fast Connect routers per POP. Additionally, you can configure 2 CPEs, custom premise equipment, to create a highly available deployment in your on-premises network. The diagram shows the recommended HA VPN deployment with 2 configured tunnels per CPE. Summarizing the connectivity options to your on-premises network, we talked about IPsec VPN and Fast Connect. This network topology diagram shows that the VCN network is connected via an IPsec VPN connection, virtual circuits to the on-premises network, and also has the Internet gateway for your VCN Internet-bound traffic. This can be a highly available and flexible VCN configuration for your applications. In this lesson, we talked about high availability concepts and how they are present on OCI components. Thanks for watching and see you in the next lesson. Hello and welcome. Now that you've been introduced to high availability concepts and how they work on OCI, let's see how we can apply that to an existing scenario. In this walkthrough, some sequences will be played at fast speeds, not necessarily reflecting the actual time that it takes to perform those operations. The initial scenario consists of 2 instances. The first instance is in a public subnet and it will hold the web server for WordPress. The second instance is on a private subnet and it hosts the MySQL database. The first step I will do is to move the web server files to an NFS share. The file storage service provides a managed NFS service that is highly available. To create a file system, go to the navigation menu, select Storage, then click File System under the File Storage area. Click on Create File System. I will start by editing the name and making the name something that is meaningful for my environment, so I will call it WordPress. The export path is the name of the share. If you try to list the NFS server, that's how the share is going to be identified. If I had a mount target, I could be selecting to reuse that mount target. In this scenario, I don't have a mount target, so I will create a brand new one. The name of the mount target is something that is used to identify it within the OCI console, so I will make something that is meaningful to me. I will then select the VCN where my components are, and then I will select the subnet where I want that endpoint to be placed. In this scenario, I will use the same subnet that the database is using. It's a private subnet because I want the NFS share to be isolated. We will skip the use network security groups at this moment because the network security group was not created yet. Now it's time to create the network security group. Go to the navigation menu, select Networking, Virtual Cloud Networks, pick the VCN that it's in use. On the VCN, select the network security group and create a new security group. To limit the access, we will use another network security group as the source type. We already have a network security group that is used by the web servers, and they will be the source that we will select. Access to file storage service requires TCP and UDP ports. Those ports are listed under the Security section of file storage services. You can enter multiple ports at the same entry, and when you create the rule, they will be split on separated rules for each port. Now that the network security group was created, you can go back and in the mount target edit and include the network security group. With the share created, it's time to connect to the web server and transfer the files to the NFS share. You can see the share using the show mount command on Linux. That will ensure that you have the proper access to the share and you will be able to mount it. At this time, we will mount on a temporary location to transfer the files. Here I mounted the NFS share on the MNT directory. On the NFS share, I will copy the HTML folder, the web server root directory. It contains the WordPress files and directories. When the command finishes, I check that the files were properly copied to the NFS share. Now that the copy is finished and verified, I will mount the folder. Stop the web server, rename the www folder, recreate the www folder empty so it can be the mount point for the NFS share. Now with the new www folder created, I can mount the NFS share on this directory. My Linux server is using SE Linux, so I will have to run a command to add the directive that allows the Apache server to use NFS shares. With the permissions corrected, now I can start the web server, then go to the web browser and make sure that my WordPress installation is working. Let me apply the changes that I did to the diagram. Moving the files to the file storage service is an easy way to ensure that they will be highly available, accessible to several web servers in a durable and reliable storage. Before adding more servers, let's add a load balancer that will distribute the incoming requests. Before creating the load balancer, I will create a network security group that will govern the access to the load balancers. I will go to the VCN that is being used by my environment, and on the network security group option, I will create my network security group. I'll be opening ports 80 and 443, HTTP and HTTPS respectively. Using the breadcrumb, I will click on Networking, and from this menu I will select the load balancer. On the load balancer screen, I will click on Create Load Balancer. When prompted for the load balancer type, I will select Load Balancer. On the wizard, I will name my load balancer. Make sure that it's a public load balancer, and I'll keep moving on the choices. For my environment, I can stick with the flexible shape of 10 megabits. I can change that later. I don't need IPv6 support, so it's time to select the VCN that I'm using and the public subnet where the load balancer will be placed. As I already created a network security group, I will go ahead and use the checkbox and select the load balancer network security group. On the next screen, I will select the load balancing policy. I will leave as weighted round robin. Then I will proceed to add backends. I will add the existing server until we create a pool of servers. The existing server will help to validate that we configured properly the load balancer. In my scenario, I'm not using SSL, so I will not check the box and move to the next screen. On the listener configuration, I will select HTTP as I'm not using SSL certificates. Advancing to the next screen, I will leave the default log options and submit to create my load balancer. The load balancer can take a couple minutes to be provisioned and another couple minutes to report properly the backend servers. Let's fast forward to the end of the process. With the load balancer in place, let's take a look on how the diagram looks. Along with the distribution of the incoming connections, the load balancer gives an extra layer of isolation. Now, I will create the instance pool and the auto-scaling policy that will adjust the pool dynamically according to the load. Before that, I will create another private subnet for the web servers. Because the load balancer is on the public subnet, I can move the web servers to a private subnet and keep them more protected. Remember that you should always consider the security best practices when designing your environment. Security counts to ensure that the environment will be highly available. I already have a network security group assigned for the web servers. I will edit and change the source type from CIDR to another network security group, the one already used by the load balancer. When I create the web service subnet, the app subnet, I will choose the regional type. A regional subnet spans across the whole region, encompassing all the existing availability domains. Moving resources from one availability domain to another in a regional subnet is simpler than when you have AD-specific subnets. The subnet is created, and now I will create an instance that will be the template for my instance pool. It will define the settings for the instances managed by the instance pool. This instance configuration will use a Cloud init script to install the required packages and make the required changes. Once the installation is complete, I'll double check that the instance is according to what I set on the script. I placed the template instance in the app subnet, So to access the instance, I will need to set up a bastion, or in my case, I will use the initial existing web server as my jump server. Check complete and ready to move forward and create my instance configuration.